Hi everyone. All right, the C4 notes today are about domain function notation and interpreting graphs. The notes start out with a couple of definitions, just reminding you about the definition for a relation and the definition for a function. So looking here, a function is a relation in which each element from the domain is paired with a single element from the range. So you can't have one x going to two different y's. When we're looking here in this first example to determine if the function is a relation or not, you want to look at the x's and you want to see if there's an input x that gets paired with two different y's. So here in this first example A, we can use the 8 as our example. 8 is paired with -3, and then 8 is also paired with -4, and then it looks like 8 is also paired with -9. And so here we can use that to determine that for this one, no, it is not a function because there is an element of the domain that is paired with more than one element from the range. Here in the next example for B, we're all set. Looking at the 16 and the 17, you might notice that the 16 pairs with 240 and the 17 pairs with 240, but that's fine. You can have different x's going to the same y. You just can't have the same x going to different y's. And so for B, we would determine that the answer is yes, this is a function. On C, you'll notice that 1 is paired with 4, and then later on 1 is paired with 7. So the 1 gets paired up with two different numbers for the output. And so for this one, we would conclude no, it is not a function. And then on this final example D, -1 is paired with +1, and then -1 is paired with -2. And so for this one, we would conclude no, this is not a function. Sometimes instead of being given a table or a mapping diagram or a list of ordered pairs, we're given a graph and we're asked to determine if the graph represents a function. And so just a reminder that the vertical line test lets you determine whether or not a graph is a function. So if you can draw a vertical line that goes through the graph in two different places or two different points, two different solid points at the same time, then the relation is not a function. So here in this next example, that's what we're being asked to determine. You're going to try to draw lines that go through the graph, and if you can draw a line that goes through the graph and crosses the graph in two different places, then the answer is no. So for example, on A, there's lots of lines that you could draw. Because this line crosses the graph in two different places, we would conclude that no, this is not a function. Similarly on B, there's lots of places where you can draw a vertical line that crosses the graph in two places. And so for B, we would also conclude no, this is not a function. C is a function. You can try to draw lines that go through this graph in many different places, but there's nowhere you can draw a vertical line that crosses the curve of the graph twice. So C is a function. And then on D, there's no line or no curve drawn connecting these points. This is a discrete graph, but notice that there are a couple of places like here where you can draw a vertical line that crosses two solid filled in points of the graph at once. And so for D, we conclude no, this is not a function. Please note here that if one of these points were open, if it was like not a colored in point, if it was an open point, then the answer to the question can be yes. And then continuing on, E is a function because there's not a place you can draw a vertical line through that graph that crosses it twice. And then F is no because there are many places where you could draw a vertical line through that graph that crosses the graph in two places. The next part of the notes give you reminders about the definitions of domain and range. Domain is your input values, it's often your x. Range is your output values, and it's often your y. All right, so the next question here asks us to figure out domain and range from word problems. The first example says you're given a 10-question multiple choice test, and your score is a function of the number of problems you get correct. You're trying to determine the domain and range. Assume there is no partial credit. We also here have to assume that the test is being scored out of 100 points. And so the domain is your input. Those are the questions that you get correct. And so on the test, there's 10 questions on the test. So you could get anywhere from 0 to 10 questions correct. So one way of writing the domain, you could write it like this. The brackets mean that 0 and 10 are included in the list. The comma means that the numbers in between are included in the list. And then you just make a note that it's only the whole numbers. So this would be the list of numbers 0, 1, 2, 3, all the way up until 10. The range is the outputs. And so if you got 0 questions right, you would get a 0 on the test. If you got 1 question right, it would jump to a 10 because it says in the directions that partial credit is not being awarded. And so for the range, it might be written like this as a list of numbers. And so this set notation is another way that you can see a list of numbers indicated for the range. So you could get a 0 on the test or a 10 on the test or a 20 on the test. And again, the outputs is a function of the inputs. So depending on how many questions you get right, that would determine your score on the test. The next example is similar. It says a concert venue holds 50 people, and then it goes on to talk about ticket cost, and you're being asked to find the domain and the range. So for this one, the venue holds 50 people, and so the domain would be all of the whole numbers between 0 and 50. You could have 0 people show up for the concert, that would be a bummer, or you could have 50 people, the maximum capacity, show up for the concert, and all of the whole numbers in between would be included in that list for the domain. The output is a function of the input, and so each ticket costs $15, and so we could write the range for this one like a list. And so if 0 people come, there would be be $0 generated. If one person comes, $15 would be collected, and so on, all the way up till if all 50 people come, then you would make 50 times 15 would give you the 750. And so that's the way that we could write our range for this one. Sometimes we're asked to determine domain from an equation, and so that's what we're doing in this next set of examples. Remember that an excluded value is an x value that makes the function value y be undefined. So an excluded value is a number that makes the bottom or the denominator of a fraction in a rational function equal 0. So here in this first example for A, we're being asked to determine the domain for each of the rational functions. So you want to look at the bottom in all of these. You can put in any number you want to for x, so long as it doesn't make the bottom of the fraction equal 0. So you can think about it. What we're going to be doing is setting the denominator equal to 0. So we don't want x minus 10 to equal 0, so x is not allowed to equal 10. You're being asked to determine the domain. And so for this first one, the domain is all real numbers. You can put in any number you want to for x except x equals 10, because that's the number that would make the bottom equal 0. And so for the next one, we'll continue in the same way. We can put in any number for x so long as the denominator doesn't equal 0. So I'll minus the 6 from both sides, and then I'll divide both sides by 2. And so for this one, I'll get that my domain is all real numbers except x equals -3, because -3 is the number that would make the bottom of the fraction equal 0, so it's excluded from the domain. The last two problems in this example are the same directions. The only thing that's different is that when we solve the bottoms, we have to solve them a little bit differently. We still don't want x squared minus 16 to equal 0, so I'll add the 16 to both sides. But then here, to finish solving, I'm going to take the square root of both sides. And so for this one, the domain has two excluded values. The domain for this function would be all real numbers, except x cannot equal +4 and x cannot equal -4. So there are two excluded values. And then similarly on D, I'll set the denominator not equal to 0. On this one, I'll t-chart. And then once I have it written in factored form, I'll use the zero product property to finish solving. I'll get that the domain is all real numbers, but x cannot equal 3 and x cannot equal -1. Those two numbers would create a 0 in the denominator, so it would make the function be undefined at those values. All right, moving on. Sometimes the graphs that we are interpreting are nonlinear graphs. So in this example, you're given a graph that shows the distance a delivery van is away from a warehouse over the course of time. Segment 1 shows that the delivery van is moving away from the warehouse, and so the first question here for A wants to know what is happening at segment 2. So notice that in segment 2, the slope of the line has changed. The line is not as steep in segment 2 as it is in segment 1. So for part A, in segment 2, the van is still moving away from the warehouse. It hasn't stopped or turned around to come back. However, it's moving more slowly than it is in segment 1. For part B, notice that in segment 6, the slope of the line is negative for the first time. And so here the van has started to return to the warehouse. Question C wants to know which line segments show intervals where the distance did not change. And so here on the graph, you can see that that's occurring at 3, at 5, and at 7. Those are the three segments on the graph where time is continuing, but distance is not changing. This question also wants us to give a possible explanation for these segments. And so it's possible that at these places, the van either made a stop, they were making a delivery, they took a break, or something like that. All right, and in the last example on this page, you're given 3 different graphs that show the amount of water in a barrel changing over time. It says 3 hoses fill 3 different water barrels, and then it gives you the information about each one. So a green hose fills it constantly, a black hose starts off slowly and then is opened. On the blue hose, it says that it's completely open at the beginning and then it's slowly closed. And so the 3 graphs are provided for you. The question on this one says, which graph best represents the amount of water in the barrel that's being filled by the green hose? And so remember from the directions that the green hose is the one that fills the barrel at a constant rate. And so out of these 3 graphs, B would be the one that represents the green hose, because B is the graph that's increasing by a constant amount. Although you're not asked to answer this part of the question, you can also make a note here just for your own reference that if you needed to match all 3, A would match with the black hose because it was opened slow at first, and then C would match with the blue hose because it was opened quickly at first, and then C would match with the blue hose because it was opened completely at first and then slowly closed. All right, let's see. So on this next one, we're determining if the graph of the situation would be discrete or continuous, and then we're making a sketch of the graph. A plane takes off, we'd assume from the ground, and climbs steadily for 15 minutes until it reaches 30,000 feet. It travels at that altitude for 2 hours, so until 2 hours and 15 minutes, it's at that altitude, until it begins to descend to land, which takes 15 minutes at a constant rate. So the entire duration of this trip is 2.5 hours. 15 minutes to go up, 2 hours at that altitude, and then 15 minutes to come down. Make a note here that this graph would be a continuous graph because it's a function of time, and when it comes to time, the in-between values do make sense to consider. And so when I graph this function, I do draw the line that connects the points. On B, it says a contestant on a game show is given $100 and then asked 5 questions. The contestant loses $20 for every wrong answer. So they start out with $100. If they get 1 question wrong, they would have $80 left. 2 questions wrong, they would have $60 left. 3 questions wrong, they would have $40 left. 4 questions wrong, they would have $20 left. And then if they got 5 questions wrong, they would run out. Make a note here that this is a discrete function because you can't get 2.5 questions wrong. The in-between values don't make sense. So on this one, although the points follow a linear pattern, you would not connect the line. The next one says you decide to hike up a mountain. You climb steadily for 2 hours, and then you take a a 30-minute break for lunch. Then you continue to climb faster than before. When you make it to the summit, you enjoy the view for an hour. Finally, you decide to climb down the mountain, but stop halfway down for a short break. Then you continue down at a slower pace than before. And so notice for this graph, I didn't provide markings for the times because not all of the intervals were given to me. So I'm just drawing a general description of what's going on. You can also make a note that for this graph, it would be considered a continuous function. While you cannot find the slope of a line that's not linear, you can find what's called the average rate of change. And so the average rate of change is an adaptation of the slope formula. So you can take the y's and minus them and take the x's and minus them. You can find the amount that something is changing over a time interval, even if it's not a straight line. So for this first example, it says determine the average rate of change from where x equals 3 to where x equals 5. And so I'm trying to find out the average amount that the graph changes over that nonlinear interval. So to find the average rate of change for this one, I'll subtract the y's, so 7 minus 1, and then I'll subtract the x's, which is 5 minus 3, and then I'll simplify. So it's really similar to the slope formula. 6 divided by 2 gives me 3, and so over that interval, the average rate of change would be 3. Same thing on the next one, I'm going to find the average rate of change from where x equals -1 right here until where x equals +2 right here. So you can also think about it like you're finding the slope of the secant line that would connect those 2 points. So I'll do y minus y, so 1 minus 4 over 2 minus -1, and then I'll simplify. Minus minus turns into a plus, so I'll get -3 divided by +3, which will give me -1. So the average rate of change over that interval, or the slope of that secant line, would be -1. All right, and the last example on the notes today asks us to evaluate functions. So remember, when it says x equals 4.5, that means that on this one, you're plugging a 4.5 in for the x. You're plugging it in wherever you see an x. On this one, there's just the 1 though. And so 5 times 4.5 gives me 22.5. So on this one, the function value at 4.5 is 22.5. And so I'll be doing the same thing on these next problems. On this one, I'm going to plug in a -2, and then be careful to follow PEMDAS. -2 squared gives me +4, and then half of 4 gives me +2. So for this one, f of -2 equals +2. This one's worded a little bit differently. It says find f of 1/4. So that's the same thing though. You're going to plug the 1/4 in wherever you see an x. And then once you plug it in, just make sure that you follow PEMDAS. So 4 times 1/4 gives me 1, and then 8 plus 1 gives me 9. So on this one, f of 1/4 would equal 9. And then lastly, on this one, I'm going to plug in a 20 because I want to find f of 20. And so PEMDAS says that I multiply first. So 70 times 20 gives me 1400, and then I'll finish by subtracting. So on this one, I get f of 20 is equal to 1600.